Very good morning, students. This is a question paper NEET 2020. Question paper code H3. We will discuss the chemistry part. What is the chemistry, the analysis of solution, we will discuss in details. So this is the first question, the question number 136. Match the following and identify the correct option. Carbon monoxide plus water plus carbon monoxide plus hydrogen, that is a synthesis gas, or we can call it as a water gas. And B option, temporary hardness of water. Temporary hardness of water is nothing but bicarbonate, salt of magnesium and calcium. So obviously this is the B answer. And then C option, B2H6. B2H6 is an example of diborane. Diborane is a dimeric form of BH3. So this is an electron deficient molecule having 6 electrons. So this is electron deficient hydride. And hydrogen peroxide. Hydrogen peroxide is not a planar molecule, is a non-planar molecule. Oxygen and another oxygen is attached to the water, a hydrogen, then oxygen having 2 lone pair of electron. So lone pair of electron occupies more space than bond pair. Then your structure will be like open book structure. So now you can see the option A is a 3, B is 1. You can see 2, 3 for A and B for 1. Only option 2 is correct. Next, a tertiary butyl carbocation is more stable than secondary butyl carbocation because of which of the following? Carbocation stability order, it is a well established. Tertiary butyl carbocation is more stable than secondary carbocation, which is more stable than primary carbocation. This is a well established stability order. This will be explained based on the hyperconjugation effect. Tertiary butyl carbocation having 3 methyl group attached to the carbocation. The hybridization of the carbocation is sp2. Then to maintain the balanced charge of the carbocation, there is a 1 sigma bond, CH bond will break. Breaking of CH bond, breaking of sigma bond is an example of hyperconjugation. So obviously your option is 1 is correct. You can see minus I effect, but the methyl group is electron donated group. Minus Fi effect is not possible. Plus R effect. Plus R effect means it's a resonance effect. Resonance effect or mesomeric effect, charge separation is possible, but here is no charge separation. Delocalization is not possible in hyperconjugation, and the minus R effect also rolled out. Option 1 is a correct one. And why this is a again tertiary butyl carbocation is more stable than secondary? The exact reason is the sp2 carbon attached to the carbon is sp3, having hydrogen is 9 hydrogen. So 9 hyperconjugation structure is possible for tertiary butyl carbocation. Whereas if you see the secondary carbocation, carbon having 2 methyl group, then it is called a secondary carbocation. It has a alpha carbon has hydrogen, then this will be the totally 6 hydrogen. So compared to 9 hydrogen from the tertiary butyl carbon, this is the 6 carbon. Obviously more resonance structure possible for hyperconjugation for tertiary butyl carbocation. So it has to be explained by hyperconjugation effects. Question number 138. What is the changes in oxidation number of carbon in the following reaction? Carbon, here is a methane react with the chlorine and it produces carbon tetrachloride plus HCl. All the hydrogens was replaced by chlorine and you are getting carbon tetrachloride. Carbon, the oxidation state of carbon in methane is at -4. -4 because hydrogen should be +1, 4 hydrogen, then it should be +4. So -4 +4, then the molecule is neutral. If we come here, carbon tetrachloride, here in this case carbon is directly attached to the chlorine. Chlorine is more electronegative than carbon. Then 4 into -1, -4 for chlorine, then +4 for carbon. So carbon is changing, the oxidation of carbon is changing from -4 to +4. Answer is 4. For this question, let us discuss next question. Sucrose on hydrolysis, it will give alpha D fructose, beta D fructose, or out of these 4 options we have to choose the correct one. We have to deeply analyze the sucrose structure. Sucrose is an example of disaccharides. Disaccharides, 2 monosaccharides having attached by oxygen, that is a glycosidic bond. To refer the sucrose, sucrose is a well established carbohydrate. When it is hydrolyzed, it giving glucose and fructose. It is a combination of glucose and fructose. Now we have to see the structure of glucose and fructose, how it is attached. This is a chain form of, that is pyranose form of glucose we have to write. Carbon is, oxygen is attached to the carbon, it is a 1, C1. Here you can put hydrogen, then this will be the O, then this O is attached to the furanose form of fructose, cyclic 5-membered ring, furanose. So it has a carbon attached to, here is CH2OH and this one. So rest of the chemistry, stereochemistry, everything's established chemistry, so that we don't need to bother about. And you can see the carbon 1. Here in this carbon 1, anomeric carbon, the hydroxy group is attached to the fructose is a beta, is alpha carbon. If it is a down, the plain bond, if it is up, if you take here, this is a beta. If it is down, this is called alpha. And the carbon C1 attached here is O, which is alpha. C1 alpha. And this is above the plan, the fructose, the oxygen is connected to the glucose. This is a beta carbon of C2. So alpha carbon of glucose, beta carbon of fructose. So this alpha D and beta D, both are stereochemistry dextrorotatory, particularly that one, CHO, CH2OH. If you take the glyceraldehyde, hydroxy group is on the right side, then it will become D. D is no way related with it, small d. Small d dextrorotatory, this is a particular confidence, this caps D used for carbohydrate chemistry only, whereas a small d and a small l dextrorotatory, levorotatory, wherever optical rotation is possible. So your compound is alpha D glucose joined with a beta D fructose, then option 4 is the correct one. Just you have to write the below and below, then only you can be able to predict the connectivity of the glycosidic bond. Option 4 is the correct.